Hey everyone, thanks for attending our talk on replaying real-time live video events with Ember. I'm Chris, I'm a staff software engineer at LinkedIn working on the video team in New York City. I'm also one of the editors for the Ember Times, so please subscribe.
And I'm Claudia. I actually also work on the video team in New York City for LinkedIn. So at today's talk, we're planning on talking about our live video product and kind of our journey and challenges that we faced with building it.
So at LinkedIn, we probably have like one of the largest SPAs in the world, all built with Ember. So if you go to like linkedin.com, that whole website is built with Ember. So we have like the feed, you can upload videos, upload photos. There's messaging, there's job searches, job listings, there's even news. And we also have like notifications. So like if Claudia likes my video, you'll get a pop-up of like, oh, Claudia is like, finds your post insightful about cats. But one of our features that we have today that we're discussing is
live video. So this is actually a product that's still in beta. We launched in January this year, so it's still growing. We're still building a lot of new features, but this is kind of the state that we're in now. So there's a live demo here, which is just one of our biggest streams that we've had, which is the Microsoft Build Conference. So if you check out the slides later, you can follow the link, but we're just going to talk about the screen recording so we don't lose where our speaker notes and slides are. So as you can see, we have the video over here on the left. But most of the stuff that we really dealt with working on the front end was kind of the side panel and stuff around the video. So we have a live stream of reactions coming in. So everybody viewing the video can tap on these buttons, kind of show their sentiments towards what's happening. And then we also have this comment stream coming in that's synced up with what's going on in the video. So if like something really crazy is happening at 1 minute, you'll see a bunch of people talking about it and know that's what that's about. And then just kind of some other information about the video that you might want to know.
So everything's time sync to the video. So like if I comment like, oh, I agree with your point, it doesn't quite make sense on its own versus having it in a point of time of the video. So you might have like different points during the live video. So we want to display the comment as the video is playing at that specific time.
And like we mentioned, we really only dealt with the front end of this app, so we didn't have to be the ones who worried about integrating with Azure to serve this live video. The stuff that was really a challenge for our team was building this interactive experience around that content. So the big things that we really were worried about was having the events be at the right time, and also having all these elements being added, removed, moving around the DOM, because that's obviously pretty stressful on your system and also on your engineers building your system. It's kind of a lot to figure out how to make it work and where everything is even located.
So what we're specifically talking about today is a replay of a live video. So a live video is something that's happening in real time, but a replay is kind of like a recorded session of that live video where we have like comments and reactions still popping up with sync to the video. At first, this kind of looks like, oh, it's easy, right? You just change the data source and you're done. You've implemented both live and replay live video. However, if we look at the whole picture, we have like the real-time service pushing down data to our client-side data storage versus a replay where we are pulling data from an API that our team built. But then everything else remains the same, and we kind of want them to remain the same because then we can reuse code for replay and live video. So if we're looking at a real-time live video, so something that's happening like right now, such as this talk, we are pushing data to our data source and then pushing it to the client. In order to associate, like if we're making a comment or a reaction, to make sure that that comment, that reaction is associated to that point in time of the video, we fetch the time of the video as you create the comment or reaction, and we attach it to the metadata of the payload, and then we post it to our backend services. They then handle everything else, which is nice for us, but as you can see, later on, we do have to consume it later on So in a live video event, when you're watching something live, you subscribe to an ID, and then our backend services would push new events as they come in, and you just consume that and display it on the client. Pretty easy. So we match if the video time equals the event time. However, in a replay scenario, we are pulling data from our APIs versus getting it pushed down to us. So this introduces a couple complex challenges that we are trying to resolve. And of course, in a real life scenario, there are limitations with the API. It is not foolproof. One of our limitations is you can't do a range query. So you can't do something like sending a request to the API for, oh, I want all the comments between the 30th second and minute and 22nd of the video. They can't handle that for many reasons that I probably can't explain well in this talk. But that's one of our limitations. Secondly, the API then splits the data into segments. So these are dynamically sized based on how many comments and reactions are happening. So it kind of makes sense if there's nothing much happening between 2 minutes to not allocate a segment for that and instead spill that over in the back end. And finally, our last limitation is all the results that we're getting back is, as of right now, sequentially based, starting from the earliest timestamp to the latest. So with these limitations in mind, let's, for example, see a high-level overview of the comments that you get for a sample live video. So if something really hot happens between the first minute and third minute, so you get a bunch of comments coming up, this might introduce a problem for your clients when you're making too many requests, especially over here. So you can't just overload your DOM, your client-side storage with so many requests that your client can handle. Secondly, if it's pretty flat, nothing much happens, and then later on the 5th minute, something really hot happens, you want to be prepared and have your comments and reactions loaded, waiting to be rendered. So we kind of have to make sure that we don't make a request too late. Lastly, if we have kind of a bimodal distribution of data, we kind of can't just request the first 1,000 comments and reactions because then you just only capture the first peak, but not the second peak of data. Because as I said, the API returns everything in sequential order, so you're only getting the first hot point and not the second hot point.
So another complication that we had to think about with replay specifically was after the live stream is ended, if you go back and are watching it in replay, you're still having your comments and reactions be time synced to the video. So that means any of these kind of hotspots and all the problems that we talked about that can come with that can actually get worse as time goes on. So if there's a really interesting part of this video that a lot of people are talking about, it can keep getting more and more popular in that specific segment.
So in order to solve these data flow issues, we've used Ember to help us isolate the business logic instead of building out all the scaffolding. So there's a 3-part into solving the data flow issues. There's the fetching problem, the displaying problem, and then finally, we need to kind of test that it actually works and it's not just works in production but not in development. So as an overview, we have 2 repeating polls, one for displaying and one for fetching, with a client-side data storage in the middle. So first up, to talk about the fetching, our first poll, we, as a high-level overview, in order to find out when to do the next fetch, we get back an end offset from the API, which is kind of when this segment ends. So you know when to fetch new data since your segment has run out. That way we can see oh, we're running out of comments for this video, so we need to fetch more events through the end segment, end offset segment. It's these ones over here. So we use Ember Lifeline, which is helps us manage our async tasks. So we use a API from Ember Lifeline called pull tasks, which does kind of a set interval except it binds it with a run loop, so we're kind of all clear with Ember and not kind of overriding it and trying to render stuff when it's not time to do so. Ember Lifeline exposes a function called pull task, and that starts a polling. And it runs kind of like this function over here, update video time. We pass that as a string to pull task, and also kind of like an ID, so later on we can clean it up. Or as I layer in on testing, we can like iterate on the poll when we're testing it. Our next polling event is for displaying the live video events. So in this case, it's a similar kind of like polling strategy where we check the local video time of the video playing on your browser, and then we see if there's like any kind of like comments that are in our store that needs to be displayed. So it's like if the event time equals the video time, and then we flush it out to the client, and the components then display it.
So now that we have all this data ready to go, how do we actually show it to people in this flashy interface that we showed you earlier? So with our two real-time events, considering reactions and comments, I'd say reactions is probably the simpler one, so we're going to start with that. So just for the creation, one limitation that we had to think about was we actually have an API limit for how many reactions a user could create in, say, a second. And we want to make sure that on the front end, you're not able to like actually hit or exceed that. So we want to make sure if you're hitting the button 50 times, you can kind of tell that you're only actually creating like 3 reactions. And then the other thing was we got this great mock for an animation for how the kind of reaction flow should look, which looks really cool, but then we went, how do we build that? And what we actually came up with was using a simple set of a few keyframe animations with CSS transitions. And we actually are just translating these back and forth on the x-axis and doing a little rotation, and then they just all accelerate upwards at the same rate. So that side-to-side animation is just kind of randomly applied. So like I said, comments, a little more complicated. The basic problem that we want to solve is showing the right comments at the right time. So the 2 product requirements that we got were that we want the default case to be auto-scrolling to show new comments, so that you're seeing the most relevant stuff kind of as your default. But then we also want to be able to pause the auto-scrolling when the user scrolls backwards so that you can actually read if stuff is really flying by quickly. So our initial approach for that was to just use a JavaScript method to scroll the list down as we add new content. And then in our scroll event handler, we check if there's still content to scroll to. So the reason for that is that the scroll event doesn't actually have information about the direction of scroll. So you kind of have to hack it together to see if you've scrolled backwards or if you've scrolled to the end of the list. So, problem here. This JavaScript scroll method actually triggers a scroll event. And since we are smoothly scrolling on a really hot stream, it's possible that you could trigger that scroll event and then while you're scrolling, trigger another scroll event, which would actually hit the scroll handler. And you could actually be in a state where it appears that you've scrolled backwards. So in a really hot stream, the interface would panic and stop scrolling. So that obviously was a problem that we needed to handle because we want people to actually be commenting. So we kind of thought it would be really great if you could just add the comments at the start of the list because then the older things would move out of the way automatically. So wouldn't it be great if we could just kind of flip this list upside down? Perfect, done, ship it. So this actually would be a little more reasonable if we add a container around that. So you can actually flip the container upside down, have that scrollable, and then flip the content within it also upside down so you can read it. And this actually looks pretty good. This will auto-scroll just like we wanted. But the problem here, if you look at the little scroll bar there, so you notice it's on the wrong side. So on Chrome and Safari, that will actually reverse the direction that you scroll. So if you want to scroll down, you'll scroll up, however you have that set up on your machine. But But actually in Firefox, this will scroll the way we wanted it to, which is interesting, and we'll get into why that might be a little bit later. So kind of scrapped that idea because it looked like that was not going to work out. So then kind of thought about using a flexbox. Makes sense, we can just change the direction that the data flows from. It's exactly what we want. And the reason that we didn't want to just do a reverse column on the list itself is because then the direction of the DOM order would not match the direction that the content actually was on the page, which would be a big accessibility no-no. So that would really be confusing for screen reader users or anyone tabbing. We actually use a container approach again. So just by applying the flex column reverse on that container and making that the scrollable item, you can actually align kind of the bottom of those two elements, and then the list is just an unrestricted height. So this works pretty well. This is actually what it looks like, and it does add the content to the end of the list, stays scrolled by default, and the scrolling direction is not flipped upside down. But it's kind of ugly. So if you noticed, this is a little jankier looking than what we showed you in the demo. Things just kind of flash in, and it's hard to tell where things are moving to. So what we actually did to handle that was take advantage of a CSS transition. So we played around with just applying a transition to the individual comments and to kind of have those slide in, but that performed really poorly. The browser was like really lagging and not wanting to do anything then. But what we could actually do was, at the same time that we add the content, translate the list down by about the height of that content. And then in the next render frame, you can translate that back up to the default position, and that gives the visual effect of a smooth scroll. And that's actually the effect that you saw in the demo. So I think it looks pretty good. I know you can kind of judge for yourself. But the problem with that, since I was developing on Chrome, so I opened it up in Firefox. Again, it looked great. I was like, okay, this is really working well. All right, check it out. And then tried to scroll backwards to test the pausing of the auto scroll. That's when I learned about this bug in Firefox, where if you overflow the top of a container with a reverse flex direction, it won't actually become scrollable, which seemed so inconvenient to me that I had to know why. So I actually looked into it. And the overflow direction in the HTML specs is determined by something called the block flow direction, which kind of refers to the direction that you read text. So something like English, Danish is a top to bottom block flow. You would read from the top of the page to the bottom of a page. So we also have specs for left to right and right to left, which is used for languages written in vertical lines. But there's not a lot of languages that are read from bottom to top. So I did some late night Googling. There's 3. And only one of them is actually actively used in modern times. And it's only able to be read by a few thousand people. So that was not really what HTML was designed to represent, I guess. So because of that, there's no writing mode for bottom to top. So there's no specification for that block flow direction. So there's no specification for overflowing the top of an HTML element. But then I thought, well, yes, there is, because that's what I'm doing. So why isn't the flex direction considered in this? So I looked at the documentation for the flex direction, which then said that it's intentional that the flex direction does not match the block flow direction. They are independent of each other. So that's actually what Firefox is respecting. It looks like it's looking at the bottom of the element and then applying a scroll bar if the content overflows that way. So that's why rotating works, and it appears to just indiscriminately scroll down in the direction of the browser as opposed to relating that to the actual element that has the scroll bar. But it looks like Chrome and Safari have actually invented their own implementation for kind of matching the flex direction to the block direction. So that's why this flex implementation works really well for those, but then That's also the reason that they appear to make the scroll bar respect the actual element when you rotate it upside down. So it's a really interesting exploration of how our crazy Ember web apps can push the limits of what HTML was designed to do. But the main takeaway for me was maybe JavaScript-powered scrolling was not the enemy. So realized that actually on Safari, our initial implementation with JavaScript scrolling didn't break. The reason for this is that Safari doesn't support smooth scrolling. So I discovered that the real culprit here was the smooth scrolling. And because that takes kind of an arbitrary time, there was no way to block adding new content while the smooth scrolling was happening. But what we could do is do an instant scroll, which is essentially what was happening on Safari, where it just jumps to new content and then salvage that CSS transition. So you can put those together to get something that looks like smooth scrolling, that works cross-browser, and doesn't have a race condition. And you can know how long it will take because it's just a CSS transition. And so that's how we got happy PMs and designers. So we also had some more simple issues that come up with comments. So one that we talked about is just too many DOM elements, so that slows down performance and also screen readers. So to handle that, we actually just limit the number of comments to 100 by removing old stuff when new things come in. But then we realized when auto-scrolling is paused, you could actually start to see elements get removed. Something you were reading might just blink out of existence. So that we had to then check that auto-scrolling is actually enabled before doing the work to add new comments. So that also means you're not just adding stuff that somebody isn't going to read. And then we actually had one more kind of display issue that was especially related to Ember. So when a new live stream comes up, we actually get a global notification to make sure that if you're online, you might want to see it. So if you were already on a live video, so maybe watching a replay of that Microsoft build video, and somebody else went live, you would click on that, and it would transition you to that new video. But we found the video actually didn't update, and neither did the comments or the reactions. The reason for this is that Ember is doing some page load optimization and not reloading those components that were already there. And what we did that was dangerous was we did a lot of the setup of those components in a init. So things like loading the video, subscribing to real-time topics for comments and reactions was all happening in the initialization of those components. So what we had to add in was checking for changes on the update adders. So checking things like, did the source of the video change, then reload it.
But what about tests? Are we just testing this in production? Do we have to like spin up a new live video every time we test this? So thankfully, Ember Lifeline gives us a poll task for function, which kind of stops the flow of the polling logic. So it only does it once. And then you can await it, and it'll poll it again. And it'll also have like a built-in await settled. So it'll reflect the changes, and then you can see if your polling logic is correct. And the other hand side of this is when we're testing logic that is unrelated to polling behavior, our polling is not kind of derailing this testing behavior. So we can kind of like hit the API once and see that we've rendered, let's say, 10 comments, and we're good to go. It's not like updating every time because the polling logic is running.
So just to recap, we're going to walk you guys through the whole life cycle of a real-time event in live video. And for an example, we're going to use our little curious reaction. So you start off with the creation of a live video event, so that'd be somebody clicking that button. And then we attach the timestamp as metadata, save that on the back end, and then we go back and fetch that from the back end, save it up in a client-side queue, queue it up for display, and then when the video time is equal to the time of that event, display it on the client, and then when the time is right, clean up that component. And that is all we had, so thank you guys for listening.